voice, and if you can't hear me, please raise your hand in back and I'll know to talk louder. I'll try my best. And I'll try to get out of the way here. So Ed and I are going to give a brief presentation on why pumping in Big Chino Valley threatens the Verde River. As soon as I find out how this works. Okay, roll that one.
Bill, I could probably do it from here if you want.
Yeah, that'd be great. That'd be great. Let me hand it to you.
I can do it. I can just do it.
Oh, okay.
I think.
Okay, we're talking about, as what everyone here probably knows, the Big Chino Valley, Sullivan Buttes, Williamson Valley, Little Chino Valley, and the Verde River running along here, and the Paulding stream gauge of the USGS runs is located about here, about 8 miles downstream from the confluence of the river with Granite Creek. The other way. Actually, it says 3 independent studies by agencies of the federal government have concluded that groundwater in Big Chino Valley discharges to the Verde River. The fact that water discharges to the Verde River is an extremely important concept and an extremely important knowledge with regard to whether or not pumping will impact the river. It says 3, but in fact there are 4 independent federal government studies. You have a 1994 report by the U.S. Bureau of Reclamation that concluded, among other things, that flows in the Verde River can be accounted for by the known recharge and sources in Big Chino Valley and from precipitation over Big Chino Valley watershed. You have a 1999 report by one of the people here and the co-author of the USGS that concluded that aquifers in Big Chino Valley are a primary source of Big Chino Springs, presently supplying at least 80% of the current flow of the Verde River. You have a 2005 study by the USGS that concluded that groundwater outflow from the Big Chino Valley occurs only as base flow in the Verde River. Base flow is simply another word for the contribution of groundwater to the flow of the river. A second study by the USGS in 2005 concluded that groundwater outflow from Big Chino Valley contributes somewhere between 80 to 86% of the base flow of the Upper Verde River measured at the Paulding stream gauge. In addition, a consultant hired by the Upper Verde River Watershed Protection Coalition to review the 2 USGS reports, 2005 USGS reports, stated that the basic finding that about 80% of the Upper Verde River base flow is derived from Big Chino Valley is hydrologically sound and has generally been believed by hydrologists since 1976. There should be no controversy over whether or not the Big Chino Valley contributes groundwater to the Verde River, and that contributes most of the flow, base flow of the Verde River today. It has historically as well. Now, since water in Big Chino Valley discharges to the Verde River, the question is, why will pumping threaten it? We'll go through this briefly. Now, you have to remember that gravity works underground the same as it works above the ground. A stream flows downhill because of gravity. Water that gets below the ground also flows because of gravity, and it flows down. It'll come up because of the pressure of water above it at times, but it's flowing because of gravity underground, the same as it flows above ground. So water is constantly moving downhill due to the force of gravity. Most cartoons that show the hydrologic cycle show groundwater constantly moving. It is constantly moving. It ultimately moves to the lowest part of the groundwater basin where it discharges to streams, springs, by evaporation, and or evapotranspiration, meaning by trees. The streams is the major place where groundwater naturally discharges. When a stream hasn't flown, when a stream is flowing after a week or so of rainfall, it's flowing because of groundwater getting into it. If it's flowing perennially, it's flowing because groundwater gets into it. Most of the flow of the Mississippi River is groundwater getting into it. So most of the flow of the Verde River is groundwater getting into it, or at least 50% of it. Next. Now, when you introduce wells, you introduce a new form of discharge in the groundwater system. You have water flowing out naturally, but now wells go in and they are also taking water out. Every drop of water those wells take out is a drop of water that doesn't get to the river. As stated by a well-established and field-proven principle in science of groundwater hydrology, the discharge of wells is balanced by a loss of water in the groundwater system equal to the pumpage. So whatever drop you take out, that's a loss to what was happening somewhere else. That water was going somewhere. It doesn't get there anymore. The loss is initially from the aquifer, meaning that the area around the well, the water is taken out, but ultimately, this cone of depression spreads out this way and this way. Amazingly, in groundwater, after a while, the decline at the well can be on the order of a foot, or 2 feet, or 3 feet, but the spread out at the same time is in miles. It spreads out this way, even though it's only dropping a couple feet this way. That confuses people. They think the system's stabilized. It hasn't. The cone of depression is spreading way out with time, and it'll spread miles. It ultimately has to spread to where groundwater naturally discharged, or you'll overpump the system and the wells will dry up. Because perpetual removal of water from storage is obviously not possible around here, the groundwater principle further states that for pumping to be sustainable, if you're going to pump your well and you're going to continue to pump it, the system has to be balanced. Either you have to increase recharge by an amount equal to your pumpage, or you have to reduce discharge by an amount equal to your pumpage. Nature reduces discharge naturally by allowing the pumpage cone depression to reach the river and reduce the amount of water discharging to the river. Okay?